Hi. I've got a serious question for all of you. Raise your hand if you know how a microwave oven works well enough to build a brand new one from scratch. Any takers? Oh, okay, I see a hand. That's impressive. Different question for you. Who here has never used a microwave to cook food? Okay, again, we've got one hand. Interesting. So what you're telling me is that most of you here use microwaves, but you have no idea how they work. Why do you trust those microwaves? Well, you don't trust them by reading the wiring diagram. You trust them because you think about what you need them to do for you, and then you check that they've delivered. And that's exactly the same thing that you're going to do with machine learning and AI. Now, what they don't tell you is that when we say machine learning, there's actually two machine learnings there. One of them is focused on building general-purpose tools, like microwaves, for other people to use. That's machine learning research, and that's what all the university courses out there are all about. And you need that long educational program if you're going to become a machine learning or AI researcher. In our analogy, which also works for machine learning, how are you going to build a better microwave than all the ones that exist today if you have no idea how these ones work? And there's a long history of these general purpose tools, and to innovate in the tools is quite hard. But most of you probably aren't interested in designing new general purpose AI tools for other people to solve their problems with. You just want to get cooking already. You want to innovate in recipes, in models. You want to use existing tools, algorithms, to solve your business problems. So you are interested in a different discipline, the applied side of machine learning. Now here's the thing. We're training people to build more microwaves. Who's training people to innovate in the kitchen? When you're going to do this at scale, it's not trivial, actually. You need to think about curating all those massive amounts of ingredients or data. You need to think about how you're actually going to solve your business problems and which business problems are worth solving, how you're going to figure out if it all works. Running that industrial scale kitchen is hard. And yet here we are training people to build more microwaves. There are warehouses upon warehouses of these microwaves out there and freely available for you to use. And yet we seem to keep suggesting that in order for you to get into AI, you have to learn how to build a microwave first. This is nonsense. So I would like you to consider joining in decision intelligence, or applied AI if you prefer, it's the same thing. Don't worry about how that microwave works. Focus more on how you're going to use it and how you're going to check whether or not it has delivered for you what you need. And your process is going to be very much like the process you follow in the kitchen, which is why I like this analogy. You're going to do a lot of dabbling and tinkering and playing as you iterate towards solving your business problem. So it's a really exciting field. Now, I also want to point something else out. A lot of businesses fail at machine learning because they've got this idea that all machine learning is the research kind. And when they open their industrial scale kitchens, you know what their strategy is? They go and they hire 20 people who've done the equivalent of building tiny microwave components their whole lives to run an industrial scale kitchen, to cook, to innovate in recipes. What could possibly go wrong, right? Like, what do these people know about cooking if what they've done is engineered bits of microwaves? It is not the same thing. These are two completely different disciplines. And one of them is this wide open space that's super useful and right for you to jump into. And the other one is the one that the world seems to imply you need to do first before you can get into machine learning. By the way, before we get any further, what on earth is machine learning? Contrary to popular belief, it is not a magical box of magic. Instead, you can think of it simply as a thing labeler. Let me show you how it works. Very simple. You're going to take your data, your ingredients, and your job here is to separate the red circles from the blue triangles. So what you're going to do is you're going to put some kind of boundary between them, a fence, and you're going to think about where a sensible place to put that boundary is. I hope you see that it's not horizontal. When you run an algorithm, it figures out where to put the fence. So it takes your data and figures out the most sensible place for the fence. And all those different gobbledygook names for algorithms that you might have come across, like decision trees and neural networks, that simply refers to the allowable shape of the boundary that can go between your data. So it doesn't just have to be a straight line, there can be some more interesting shapes that you can fit between. Then once the algorithm has finished, once this microwave built for you by researchers has done its job, what comes out is what you've wanted all along, which is a model. What's a model? It's just a fancy word for recipe. It is the recipe that you're going to use to turn new data inputs into correct outputs or decisions. So in comes a new data point, and you give it the label of red. See, it's easy. So why should you be excited by this stuff? This is a picture of my pet Huxley. And when you saw this, you took in some pretty complex information through your senses. And you just know that that's a cat. How do you know that? And if I show you this one, you're not fooled, you still know that it's a cat, even though those combinations of pixel colors are very different from one another. Now, if we wanted to get a computer to do this task for us, let's think about what we'd have to do. If we went the traditional programming way, we would have to come up with the instructions that turn those pixel data into the correct label. So what does a traditional programmer do? A lot of programmers in the audience, you know this. The programmer communicates in some way with the universe, channels the universe, thinks really hard about the problem, and then comes up with those explicit instructions by hand to say exactly what must be done with each pixel to turn it into the label cat. But in order to write those instructions, you have to be able to come up with them. So what are those instructions for taking the cat pixels and getting the label cat? You don't know, do you? Because think about it, your brain has had eons of evolution, and now it just does this task. You don't know how your brain converts pixels into labels, neither does neuroscience. So how are you going to handcraft that solution? You're not going to be able to solve this task the traditional way. But wouldn't you much rather do it a different way in any case? Wouldn't you much rather say, hey computer, here's a bunch of examples of cats, here's a bunch of examples of not cats, now you go figure it out. Right? That is the essence of machine learning. This is where we do our thing labeling, not with explicit instructions, the traditional way, but instead we're going to do it with examples or data. That's the whole point here. Now it seems really simple, but it's incredibly powerful. Because for some tasks, you cannot solve them by coming up with instructions because you cannot come up with the instructions. You cannot express those instructions. They are ineffable. Machine learning and AI give you a way of automating what's ineffable. Even though you cannot come up with the instructions, you can still get the job done. This is incredibly powerful. But it's not science fiction and robots and all that. All it is a new programming paradigm. It's just a different way to talk to computers. And think about this. When you give instructions To your friends, when you want them to learn how to do a task, you might give explicit instructions, or you might give them the instruction of, hey, look at me do it a few times, and now you've learned what I've done, you try it. We already have both modes of communications with humans. Sometimes we prefer to explain ourselves with instructions, sometimes we prefer to explain ourselves with examples, but traditional programming could only talk to computers one way. Machine learning and AI unlock that second mode of communication. Now we can express our wishes to computers both ways, the ways that we express our wishes to one another. That is why it's powerful. And it unlocks a whole class of new tasks that we could not solve the other way. So this is why it's the future. It's incredibly useful. But because we are automating the ineffable, those instructions, right, they're pretty complicated. If they were simple, we could have just come up with them ourselves and just solved it the traditional way. And frankly, that's my advice. If you don't need AI to solve something, don't use AI. It's a waste of everybody's time, and it's much harder to maintain that complicated thing in production if it was something that you could just have written a simple instruction for. But if you can't solve it the traditional way, you end up with these complicated things you can't wrap your head around. So you have to switch your focus from how does it work, because those instructions become unreadable to you, to does it work? But that's not so uncomfortable. You already do that in your lives. You do that with microwaves. You use microwaves that only one person in my audience here knows how they work. You take medicine that science proves has worked, and yet scientists cannot describe the mechanism of action. One such drug is a headache drug, brand name Tylenol in the US. Science doesn't quite know how that thing actually cures your headache, and yet, provably it does. Now, if you're excited to start using this, where do you get started? This thing labeling, those labels, they're little decisions. So think of this in terms of the decisions that you want to automate. Here are some examples when you start thinking creatively about labels and decisions. Maybe what you want to do is protect kids when you're making baby food products from spoiled ingredients, so you want to automatically label the ingredients before they go in as safe or spoiled. That's a label, and these are all real applications that are done on Google Cloud Platform with AI. So, safe or spoiled, that's a label. Similarly, satellite image. You want to clean up satellite images and you want to remove the clouds but leave the snow. You don't want to have to go by hand and pick out every white pixel. Cloud or snow, that's a label. AI helps with that. Then, what about the right setting on a cooling system for a data center? That's also a label, and we did this at Google with one of our data centers. Before, when we used to have human programmers and teams of data scientists go and have a look for areas for improvement in that climate control system, find some ways to make a change to make it more energy efficient, you could get maybe a 1 or 2% energy improvement, and that would be amazing. And that actually is amazing, because data centers are expensive to run, they're energy hungry. Now, when we let AI do this, what do you think the energy improvement was there? What am I hearing? Any guesses? 40%. That's not just money saved. That's a huge reduction in carbon footprints. It's great for the environment. Another kind of labeling you could do if you wanted to take the speech that I'm giving and provide captions, those are labels, taking speech and turning it into text. Or the winning move in a game of Go against the world champion, that's also a label. And so is what to do with the steering wheel on a self-driving car. All of these are little decisions or little labels. And when you think in terms of those, you're coming up with creative things that you can do with AI. These are all real applications, and there are many more like them. But how are you going to actually know that it works. If you don't know how it works, if it's too complicated to read and wrap your mind around it, you're going to do that the same way that a professor assesses their student. If you want to check that your student knows how to do calculus, don't just take their word for it. They say, "Professor, I know calculus," and you're like, "Great, A+, you pass." Don't take their word for it. But also, don't go taking a scalpel and digging around in the brain. Don't look inside and see how they implement the calculus inside the brain. Instead, give them a good exam. Because testing is what keeps you safe here. Think up a relevant exam where if they were to pass that exam, that means that they are qualified to do the task that you need them to do. And so, of course, your exam shouldn't be about can they dance ballet if you're trying to make a calculus student. It has to be relevant. And it has to be rich enough and big enough to cover the sorts of situations in which you want them to practice their calculus. Exactly the same thing for machine learning. And please, this is one of the biggest dangers, do not give your student, whether it's a human or a machine, a final exam that consists of questions that they have already seen before. Because you know what they do then? They memorize their way to a perfect score. And then when you ask them to go and perform in real life, they are hopeless. You don't want that with machine learning, you don't want that with human students either. That's what the whole overfitting thing in machine learning is. You can avoid that by testing on new examples. And then something that I tell Google engineers if they're going anywhere near machine learning, I tell them to pretty much tattoo this sentence on themselves. The world represented by your data is the only world that you can expect to succeed in. Datasets are like textbooks. In fact, textbooks are datasets. And these textbooks are what you are using to teach your student. So, a huge danger in both teaching and machine learning is giving your students some stupid textbooks. Because all they're going to learn is what's in the textbook. So, you want to teach your student calculus? Please don't give them a Japanese-English vocabulary pair dictionary. They're going to find some patterns. They're going to learn some connections between the English and Japanese, but that's not going to be the task that you want them to do. It's not how you get a calculus-enabled student. There's a lot of folks who think that data is magical somehow. Data is just information. We take information in through our senses all the time. Sometimes it's relevant, sometimes it isn't. Similarly, textbooks, sometimes they're useful, sometimes they're not. Please don't go pronouncing data with a capital D as if it's magic and just by having a data set, everything is going to be great. The quality of your data set, of your textbook matters. You have a bad textbook, you'll end up with a bad student. So please make sure that you've thought about what's in your textbooks. If you test well and you use good textbooks, you will avoid the big dangers, and machine learning will be much easier than you think, because the rest just boils down to getting a kitchen full of appliances, algorithms, which you can get a machine learning kitchen from Google Cloud or academia, free pretty much. And then you go and dabble and tinker and play and iterate towards a recipe that does what you need it to do. And then, remember, test it carefully. It's as easy as that. We're living in a really exciting time. The world is collecting more data than ever before. We're storing information. Let's make that information useful. Let's use it to automate tasks that we had no idea how to automate when we had to come up with instructions. It's a really exciting time to be alive. So I hope that you're excited to dive in, have fun, because your machine learning adventure awaits. You don't need to go and get that PhD. You can just dive right in and start having fun. When I hear people say that they need to go get an advanced degree to get started with machine learning, that sounds to me like saying I couldn't possibly use a microwave until I've built my own. There's no need for that. You can all start with this, and this is the future. Because so much of what we do, we can't say how we do it. We can only say whether we've done it right or wrong. Thank you very much. I hope that you're excited.